Hello, grade 11s. I've been told that our ideal gas law question on page 29, question 2, was somewhat confusing, so I thought I'd take a moment to explain what was going on with that one. In this question, we're told that we've got 1.09 grams of hydrogen. So there's our first number that we're going to deal with, which is going to be grams of hydrogen. Now, grams is a measure of mass, and it's in a container that's 2 liters big. So 2 liters is our next number that we're going to know, and that's going to be our volume. And it's going to be at 20 degrees Celsius, and that's our temperature. They want us to find the pressure. Now, because we've only got one instance of volume and temperature, pressure, I can tell already this is an ideal gas law question. And anytime we have an ideal gas law question for a mark, you're going to get a mark for writing PV equals nRT. This shows me that you know which gas law applies to the question, so that's why it's worth a mark to me. So we're trying to solve for pressure, which means we're going to need volume, which we know. We're going to need the number of moles, which we don't have yet. We're going to need a gas constant, and we're going to need a temperature. Now, we've been given temperature, but it's in the wrong format. We have 20 degrees Celsius. So to this, I'm going to add 273, and I'm going to get 293 kelvins as the value that I'm going to use for temperature. So this is going to be my temperature. Okay. I also need to calculate the number of moles. Now, this is something that I probably won't ask you guys to do on our unit assessment right now because we haven't taken stoichiometry yet, but I did post a quick video on how to do this. So to change grams into moles, remember moles is the number of groups. I want to know how many groups there are in this many grams. You start with what you know, and what I know is 1.09 grams. And what I need to do is to use the molar mass of hydrogen. So I'm going to draw a big long line, and I'm going to chop that off, or some people like to draw a times sign. And what I need to know is how much does hydrogen usually weigh? Now, on our periodic table, it tells us that each hydrogen atom weighs 1.01 grams. So this is H2, it's groups of 2. So I know that every 1 mole of hydrogens is going to weigh 2.02 grams. Okay, grams on the top is going to cancel grams on the bottom. We're going to go 1.09 divided by 2.02, and that's going to give us an answer of 0.54. And since we have the units moles is the only one we haven't canceled, the units of moles is what this is going to come out into. So this is my N. So we're looking for pressure. We have a volume of 2 liters. We have the number of moles as being 0.54 moles. R we still have to pick, and the value for temperature is going to be 293 kelvins. Now, how do I pick a value for R? Well, it depends on what you want your units for pressure to come out into. So for the purpose of this example, I'm going to use, say I want my pressure units to come out in atmospheres. So I'm going to go to my periodic table. I'm going to look on the back on my cheat sheet side. I'm going to say if I want my answer to come out in atmospheres, I have to use the value of 0.082 in place of R. So in place of R, I'm going to put 0.082. So now I want to solve for pressure. So on your calculators, you're going to go 0.54 times 0.082 times 293, and then you're going to divide that all by 2, and the pressure that you're going to get is going to be 6.48, and because we picked this value for R, my pressure will be in atmospheres. Now, if you picked a different R value, for example, if you just substituted in 8.31, then the pressure would have come out in kilopascals. Had you picked the number for 62.4, your pressure would have come out in millimeters of mercury. And any of those could be absolutely correct. So I hope this helps a little bit.